All right, so let's talk about word problems a little bit. So here we have a word problem that represents an inequality, but we kind of need to decode it and figure out which words are talking about which inequality symbols. So the Cobb Hill Middle School North football players have a game to compete in today. The state rules indicate that the maximum temperature they can play in is 95 degrees. Okay, I'm going to go ahead and just pause there. The maximum temperature, what that does is that establishes a limit, right? We've got a maximum of 95 degrees. Early this morning, the temperature was 67 degrees. There's another number, thinking that's important. The temperature will rise d degrees. We have just found our variable, okay? And that's how much it's going to rise throughout the day. Write, solve, and graph the inequality to show the values of d that will allow the boys to play in their game. Okay, I like to start word problems with the end in mind, okay? So we know that the answer, per se, usually we've got like a problem, the symbol, and an answer, right? The answer to this is that 95. That's the limit they've given us, okay? We know that the actual temperature that day needs to be less than 95. Now, where did I get less? Less isn't anywhere in the problem, right? But it says that the maximum temperature is 95. So maximum means that we can't be above it, right? If you picture a thermometer over here, okay? Picture a thermometer, and here's 95 degrees. Well, we can't go 100, right? The maximum is not going to include that, but we can go below it, which means less than. So the temperature right here needs to be less than the 95 degrees, right? Now, maximum also implies that it can be 95 degrees, right? That means we need to have the equal to symbol underneath. So our temperature over here, once we get to it, needs to be less than or equal to 95 degrees. So then I see, what is the temperature right now? Well, early this morning, the temperature was 67 degrees. Okay, that's where we're at right now. But then it's going to rise d degrees, right? Rising means going up. So we're going to add d degrees, okay? So there's our actual inequality. We can now take this and solve. What's important here is that a lot of y'all can find these answers mentally. You can find them without actually writing anything down, but we want you to actually write the inequality before you solve it. We want to know that you can translate words into an algebraic expression or equation or inequality. So we're now going to take this and solve it, right? We know how to do that. We're going to subtract 67 from both sides of our inequality. That means d has to be less than or equal to, we solve, we borrow, 28 degrees. Okay, so let's try another one. So Disha spent $29.75 on a t-shirt at the Taylor Swift concert. She took $40 to the American Airlines Center, is what that's supposed to say, and still needs to buy a gift for her friend Lori. Write and solve an inequality that shows how much money M Disha can spend on her friend, right? Let me just correct our typo. So if she's starting at $29.75 and she took $40 and she's about to buy a gift, we need to compose all that into one inequality. So we've got the problem part of it, we've got the inequality symbol, and then we've got what we normally call the answer, right? So if you're looking up here, we need to figure out what the limit is, what constraint they've put on this problem. Well, if you think about what is constraining her, what is keeping her from just spending all the money in the world, it's that $40 that she brought to the concert, right? So that's our limit. That's the constraint we're going to put on the end, okay? Similar to the last problem, we need to think, is $40 the top number she can spend, the bottom number she can spend? Can she spend more? Can she spend less, etc.? For some reason, I always like to look at these vertically, okay? So if here's the money she can spend, $40. Can she afford to spend $50 while she's at the concert? No. Can she afford to spend $30? Absolutely. So we want numbers that are less than 40, okay? So my inequality symbol is going to face that way. Now, think about yourself. If you take $40 to the concert, can you spend $40? Well, yeah, I mean, you'll bring nothing home, but you can actually use $40. So we're going to go ahead and make that less than or equal to. You'll find that in a lot of real-world situations, we're going to be using less than or equal to and greater than or equal to. Not often is it just going to be less than or just greater than in the real world. So now we have to include that $29.75, okay? So she has already spent that. Now some of y'all are thinking, oh, we should subtract it off, right? But that's what we're going to do when we solve it. Let's consider that part of what's going to make up all of her money that she's spending, okay? So we're going to add to that the M that she's about to spend on her friend, right? Altogether, this needs to be less than or equal to the $40 she has in her pocket, okay? So now we'll solve, which is where a lot of y'all are wanting to subtract, right? We'll subtract $29.75 from both sides. So M is less than or equal to, what would that be? She's got at least $10, $10.25. There's your answer. Now again, let's kind of decode this answer. This means that she can spend less than or equal to $10.25. So can she buy your friend a gift that costs $5? Sure. Can she buy your friend a gift that costs $10.25? Sure. But can she buy one that costs $11? No. At that point, she will be over her total. Okay, one more problem. Kai needs to practice her trumpet at least 55 minutes a day. She has already practiced for 30 minutes at school during a private lesson. Write and show an inequality that shows how many more minutes she must play for the day. Okay, so they've established our variable is this M, and it stands for the minutes that she needs to continue playing her trumpet. All right, so again, we've got a problem, we've got an inequality, and we've got our little answer portion. So the last part, the answer portion, needs to be the constraint, right? The limit, the maximum, the minimum, whatever it's going to be. So looking up at the problem, she needs to practice at least 55 minutes a day. Now, a lot of y'all see that at least and think, oh, less. You connect least with less. Now, that's not always the case. Sometimes it is, but please do not make that mistake by seeing a word and automatically writing a symbol down. Really think about it before you get going. So we can go ahead and put the 55 down here. That's the constraint, right? But again, let's think about it. Draw vertically. Here's 55 minutes. Her mom wants her to practice at least 55. Well, if she only does 45, will her mom be happy? No. If she does an hour, 60 minutes, will mom be happy? Yes, right? So we want to actually go above the 55. We want more than 55. So what's over here, her practicing time needs to be more or equal to 55. Again, notice it's greater than or equal to because her mom should be happy if she really does that 55 number. That's what her mom said. So if she does 55, she should be good. All right, so it says she's already practiced 30 minutes, but now she's going to continue to practice. So we're going to add to that M. We don't know how much that's going to be yet, but altogether, again, this just needs to be more or equal to 55. So now we solve. Subtract 30 from both sides. M must be greater than or equal to 25 minutes. Okay? So again, can she practice for 3 minutes? Well, no, because 3 is not greater than or equal to 25. Can she practice for 50 more minutes? Absolutely, because that is greater than or equal to 25. Alrighty.